Welcome to Chibuzor Mathphysics. In today's video, we'll be going through probability and statistics. In case you are joining us, you might need to refer to the previous video where we give a simple explanation on what is probability and statistics. And today we are going to deal with question number 4, having covered question 1 up to 3 in the previous videos. And the question says that the random variable x has a probability function as indicated below, and you can see that the probability of the capital X is equal to the small x when kx ranges from 1 to 3. Then kx plus 1 is simply x to be equals to 4 and 5, and k has been seen to be constant. So we have to find the value of k and then find the probability that x is less than or equal to 2. We find the probability that the value of x for which the probability of x is greater than or equal to x will be 17/20, and hence in the last two we need to sketch the graph of x. So let us handle this question. We are evaluating this particular question number 4. Question number 4 is here. Let us look at question number 4. Good. The random variable of x has a probability function. Just before I dive into calculation, I would like to mention the relationship and the difference between the discrete random variable and the continuous random variable. So this also is discrete, but there are two kinds of discrete random variable that you might need to pay attention to. If we talk about discrete random variable, if the random variable is a discrete random variable, it simply means that the probability mass function is called the PMF. And what we are saying is that x is discrete, then it takes the form of f of x. It takes the form of, let's have that written down. Let me take a different color. It takes the form of f of x. F of x is discrete because it will be, this is the function of x, that the probability of this function, the capital X, must be equal to the small x. And that's exactly what we are saying, that the probability of this function is discrete. And also, how also do you know that the function is discrete? It takes a finite number of possible values. It takes a definite number of possible values when the function is discrete. It is also called integers or rational function. So we can see discrete random variable as rational functions. So they are called rational functions. As we dive into calculations proper, you will understand why they are called rational functions and why you should pay attention to them. What if the random variable is continuous? It is continuous means that it takes any value. It could take any value, not a fixed number of possible values are taken. But in terms of discrete, it takes only a possible values, not any value. But in terms of continuous, it can go with any value. That's why when we deal with continuous random variable in probability and statistics, we tend to evaluate the area under a curve because we are going to apply integration. But then if we are talking about discrete, we simply need to use summation. So in the discrete random variable, we shall be using summation. That is x will be from some value to I up to maybe we can have some k here, or any amount that we might be given, then we have kx, and we evaluate that. But if it is continuous, we simply need to apply a value of integration, and this is exactly what we should be doing in this video. So let us tackle the fourth question. Okay, so let us have our solution. We have been given that the function is p, that is the probability of x, is given by this kx. So let us say that it means that the function f of x can be written to be equal to the probability of this capital X, which is equals to small x, and this will be, we have kx, and kx, when x ranges from x is equal to 1, 2, and 3. X is equals to 1, 2, and 3. Then we have k in terms of x plus 1, and this also takes the form of when x is equal to 4 and 5. 4 and 5. We are simply trying to do this as it is indicated. And then we have 0. Here it simply means there is no other value, so we can have 0 here, which is otherwise. So we have this together. Good. So this is the first way we start from here. So now we might need to recall that we have our formula, which says that summation of x of this probability function must be equal to small x. If you recall this, and all this must be equal to 1. Remember, in our definition, I says that the probability mass function of this discrete random variable must be equal to k. That is to say that it is constant. It means it must be equal to 1. That implies that we simply need to evaluate using what we have. So it implies that the summation of x equals to 1, as we have above, up to 3 here. Remember, the first question is to find the value of k. We are here trying to find the value of k. So to find the value of k, we have kx here, kx like it is indicated, kx plus the summation of x equal to 4. The summation of x equals to 4 up to 5 of k into, we have x plus 1, and all this must be equal to 1 according to the formula and according to our definition of what discrete random variable is. This will imply that k will be given by 1 plus 2 plus 3. The summation of 1 up to 3 simply means we add 1 to 3, and plus k, which is a constant, up to 5 plus 6. Remember, here we have x plus 1, so 5 plus 6, and all these must be equal to 1, because remember, we have 4 and 5. 4 and 5 means 4 can take x to be x plus 1, which will give us 5. And then 5, we have 5 here, so 5 take the form of x, so 5 plus 1 is 6. So that's what we do, and that's how we get 5 and 6. So we add this together. If you add 1 plus 2, you have 3. 3 plus 3 will give you 6. If you add together with this, 6 plus 6 is 12, plus 5, it is 17. So we simply have 17k. 17k is equal to 1, because we have our 1 here. Therefore the value for k is equals to 1. over 17. And this is our first solution. And now that we have evaluated the value, we have found the value for k, we can go ahead to use it to find the probability when x is less than equal to 2 in the second question. So let us find the probability when x is less than equal to 2. So let us write here the probability of x when it is less than equal to 2 will be given by summation of x equal to 1 up to 2, because x is less than equal to 2 of this function x over 17, because we have 1 over 17, so we can have it x over 17. This simply means that we will have when it is 1, it is simply 1 over 17, so it is 1 over 17, plus when it is 2, it will simply be 2 over 17. So when we add this together, we will simply have 3 over 17. And this will be our second solution. So the third question said we find the value of x for which the probability of x is greater than equal to x, and it is equal to 17 over 20. 17 over 20. Here we might do a little bit of computations in order to arrive at 17 over 20. So let me get rid of this, but I have more space to do this. Okay, so let us see the probability. This is question C. The probability of x greater than equal to x, and this must be equal to 17 over 20. 17 over 20.